last time we put together a move state for our player so he can move left and right along the ground. But now we need to add some verticality here. So today we're going to put in a jump state. So let's get cracking on that. So actually last time, real quick, before we left, we tested our game to see what would happen, and we saw that there was in fact no link at all visible on the screen. So I decided to do a little debugging, as you do, right? So first off, I'm just going to show you a little bit of my process here because, you know, everybody needs to know how to debug, and this is how I did my debugging. So first off, I put together this little thing here. So actually I have it over on my test project as well. It's just I debug output all the information about Link's position, his current activity, his state, if he's next to a wall, etc. Any information I need, I output here in the draw GUI event. And you'll probably want to put something together like this as well. You'll note this little bit of clever drawing right here. So we have an I at 0, then we say plus plus I times spacing, and that causes us to increase I by 1. So this now becomes 1 times spacing 8, 2 times spacing 16, and then adds on to the 32. And there's several different variants of ways you can do this. You can do I plus plus if you prefer, or whatever. You just have to adjust the math according to however you set it up. So anyways, in this case I do plus plus I. That way I could basically, well, you know, I could start I at 1 if I wanted to actually, and then I could just do I plus plus from there. Anyways, doesn't matter. So anyways, I put all this information in, and let's go into the game here and show you what it looks like. Now that I'm done babbling. So as you can see, Link still isn't there, and we do definitely have... Oh, look, he's touching that wall. You can definitely see that. And he's moving around at our current X speed, our desired speed like we want him to, right? And his X position is 442, and his Y position is 204. The Y position at 204 is something that I adjusted down here in the... save create. Well, not in save create. Remember, we have the entry direction thing, and then we tell it that the entry direction is no one. And in our create event, we have this check here. So this was kind of my first thought. Oh, maybe he's not sending his XY position correctly. So I thought, okay, well, I'll just change that around a little bit to make sure that it actually goes to the right place. And yes, he does go to the right place, and he doesn't move around. So, yeah, I did all that, and then I just suddenly remembered, oh yeah, I have a draw event, and I didn't put anything in it. That's why he's not drawing. So it's very simple why he's not drawing, but we'll fix that real quick here. Put in this little visibility check. If not visible, exit. We want this in here so we can kind of adjust when Link draws without actually changing his visibility parameter. Because we might want to draw something else, you know, we might want to draw like an effect or something, even if he's not visible. I had a specific reason why, but I can't remember off the top of my head exactly why. And for the time being, we're just going to put this in here. Draw sprite ext, etc., etc. This is equivalent to using draw underscore self. But I just have it all written out because I want to be able to control each of these variables more specifically. So that'll bring the Link back into the picture. So for the moment, though, we're going to go back to the states, and we're going to put in that jump state here. So what is Link doing here? Let's move over to my jump state. All right, so what are we going to do here? So if the player presses a button, let me zoom that in for you, actually. I wish it would do this automatically, otherwise I forget it every single time. If input is pressed 0, so player ID 0. Again, remember you can set that up to a variable which you can change if you have multiple players. If input affirmative, so if the zero input, if the player zero input is the affirmative input, and that's been pressed rather than released or held, then we want to activate a change into the jump state. Alternatively, if we have walked off a ledge, presumably, because we are no longer on ground, then we also want to go into the jump state, but we're going to do it slightly differently in this case. So if we walked off the ground, we don't want to have the player jump, so we just put them into the jump state so they fall, and swap over to the correct state here. And if you remember correctly, our methods, we have the change state, which sets the frames of state to 0, the previous state to the current state, or, well, and then state to the new state. And sprite index, we change our sprite index to the index of the sprite that is necessary for the state. And the image speed, set it to 0, and the image index, set that to 0 as well. Then we execute the new state and exit, because if we don't exit, then after executing the new state, it'll just come back and try to do the rest of this state code, and we don't want to do that. Otherwise, you end up with an infinite loop, because it'll, yeah. So we have a reset input buffer. So actually right here, remember we want to reset our input buffer because when we press affirmative, it holds that information for about 3 frames. And by doing this, we set our input buffers back to -1, which basically turns them off, which eats our input. Change state, player state, well, it doesn't eat our input, I guess I should say, because the affirmative action is still in the input buffer as actually being pressed. If we were to reset our input action to nothing, then that would eat the input completely. But this eats the input buffer at least. Change state, player state to jump, current Y speed. So in this case, we're going to increase our current Y speed based on the ABS of our current X speed. So if we are currently moving at the full walk speed, then we want jump speed minus 0.5. Jump speed is a negative number. Negative 15.5. And if we are at our maximum speed, we want to add in an extra 0.5 to that, which gives us a few more pixels of height. Otherwise, we want to jump at just our normal jump speed. So this is actually a really useful effect in a lot of games. You'll see where when you're running at full speed, you'll get more jump height. You'll especially remember this in Mario, where if you're trying to jump onto a block and you're directly underneath it, if you aren't at full speed, you won't be able to jump up onto the block. But if you move a little bit away and then run back and jump at it, you'll be able to get to the top of the block. So if I'm on the ground as false, so yeah, remember to set our on ground to false when we jump, because we were previously on the ground in our ground check, but now we no longer want to be on the ground because we are now in the air, presumably. So now that we have set up our ability to move over into the jump state, let's actually create a jump state itself. So we are going to go to our other user event 1. And here we are going to basically copy and paste this entire thing, because we're going to use a lot of the same code in various different formats and ways that we'll set it up in here in a second. So obviously, when we're in the jump state, we don't want to be able to jump back into the jump state. That would not make sense unless you're going to do a double jump. But if you're doing a double jump, you would probably have a variable in your jump state that would let it work properly for that, but rather than actually jumping into a new state. So we're going to eliminate this bit here, and we can't duck while we're in the jump state, but we do want to move back into the move state if we land. And we can't do a standing slash, but we can do a jumping slash. So we'll have that in there as well. And of course, we'll get to these states later on when we actually add in player attacking. For our acceleration, actually, let's go in, since we're kind of on this state change setup here, let's do the same thing again. So if on underscore ground, so if we take that we're on the ground again, then we simply move back into the player state. Change underscore state, player underscore states dot landing. So we don't actually move directly into the move state. We go into this landing state, which is similar to the move state, except we're basically just in a crouch while in this position. So we'll get to that in a little bit as well. Y underscore fraction underscore is equal to 0, because we don't want to have our Y fractions follow us. Current underscore Y underscore speed underscore is equal to 0, because we've hit the ground and we don't need to be moving anymore. Underscore user state underscore, and last but not least, our exit. Now our accelerations are going to be somewhat different because we're now moving in the Y direction as well as in the X direction. So let me pull that up. Ah, yes. So first off, coyote time. So typically, you'll give your player a couple frames after moving over a ledge in which to jump. So in this case, we have set, so if frames in state are less than 3, so that says basically if you got 3 frames to press the jump button after walking over a cliff, if you remember correctly. Move that over to there. We have the option to go into the jump state when we walk over a ledge. So in this case, you have 3 frames after walking over a ledge to activate your jump. So, and our current Y speed is greater than 0, so that means that we must be going down. We don't want to be able to. We don't want to be able to jump if we are going up already. We don't want to accidentally activate it somehow that way. No plus equal here, since you're going to want to disregard prior falling speed. So basically we're saying, okay, if you added it plus equal, then you would get your jump speed, but it would also include the plus a couple pixels in the downward downward acceleration that you've already accumulated. So by doing this, we negate those downward speeds and we just immediately jump straight up. All right, and I'm going to put some more spaces in here so that we can separate our code from the new code. Variable jump. Very easy. If the input is not held, affirmative, and our Y speed is less than or equal to -2. So remember, we start off at -16, and as we gain gravity momentum, we go from -16 towards 0 towards our fall speed, right? So as long as we're greater than, if we're less than or equal to -2, then multiply our speed by 0.25 if we let go of the input button. And that's variable jumping. It's very simple. Our X input. In this case, we're going to bring you back over here. X input equals, this does not equal 0. Y is current X speed. Airspeed, we want airspeed instead of walk speed. Times X underscore input. And instead of air accel, we want, instead of ground accel, we want air accel. And air friction over here. Oops. All right. So what we do here is basically the same thing as in our move state, except now we've swapped our variables from the ground acceleration variables to the air acceleration variables. Now, currently I have airspeed as the same as the walk speed, so you can move as fast in the air as you can while walking. I have air friction at slightly different from ground friction. In all reality, I believe it's actually 0 in the game, but I have 0.01 for, well, yeah, just part of my testing, but yeah. It's 0 while in the air because that's the way it was in the game. And air accel and ground accel are also the same here. But again, you can change this to whatever you want. You know, if you want them to accelerate faster in the air for whatever reason, like a jetpack or something, then you could make them accelerate faster in the air. So that's a very useful feature if you want to do that in the future. And last but not least, we need to check for a wall. So if the wall is on our left and sign of x input, wall on our right, or the sign of x input, current x speed is equal to 0, applied x speed is equal to 0. All right, that's good. So, okay, now last but not least, apply our gravity. And as far as that goes, very simple. Current y speed is equal to approach y speed towards fall speed by gravity. Applied y speed is equal to current y speed. It's the exact same thing as the x input. So that's our accelerations. Speed fractions will be very similar. In fact, completely the same. And they're pretty much the same in all of our states, really. Same thing for collision and movement. Yeah, it's all the same. So last but not least, our animation. Animation is going to be slightly different because we aren't going to be going into our idle anymore. In this case, we have just if current y speed is less than 0, so if we're currently going up, then manual sprite change is true, and we should be using the duck sprite. Because Link has, when he's going up, he's in a sort of crouch position while he does that. Then last but not least, image x scale is equal to facing direction equal to dir4.right, 1 or -1. So basically like this, except this was, I didn't update it to include the, I hadn't updated it to include the image x scale ABS stuff so that you could have it whatever size you want. That was a later implementation that I came up with that I'll probably implement more often in my next tutorials. I mean, it's not really used much in the NES that I know of anyways. Well, you probably, I don't know if they actually did it, but no. I don't think they actually did anything like that, but you can, like I said, you can blurp your image x scale from 1 to -1 over a period of time to give you a Paper Mario flipping sort of look to it when you move left and right. So that's why you would kind of want this kind of stuff. Frames in state ++. All right, so that's all done. So I hope you can see how setting up your states is like this, you have a very standardized sort of format, and it really makes it easy to add new animations and stuff to your player. Because now all you have to do is say, okay, well, if I want my player to, let's see, trip over a can when he walks over it, then all I have to do is go add event, other user event, whatever event, and put in a move state, or put in trip state as my name for it, copy and paste all this stuff into there, say, okay, well, when I'm in the trip state, I only want to be able to go back into the move state or possibly into the dead state if you're doing it that way. But in the case of my state, I have dead state coming out over here. So, you know, you would just have it in the move state, figure out how you move into the move state. What is my acceleration during this time? Well, the player can't actually increase or decrease the speed while he's tripped. He's just sort of fixed. So we just have them at a fixed speed during this time. And then you could just say, okay, speed fractions, we'll just leave that alone. Collision movement, just leave that alone because he's still moving and everything exactly the same. Animation, make sure he's got the right sprite and he's facing the right direction. And that's it. You're done. You just made another state. That was easy, wasn't it? So that's the kind of what you are doing here. You're setting up a really easy framework that you can use to expand your character and anything else very quickly and very easily. So let's see if we can implement that with our landing state. Landing state is user event 7. Whoops, I didn't want a path. User event 7. And copy and paste all of our code in here. And hit control, oh, not control, control in. Speed fractions still the same. Collision movements are still the same. Animation, we have no animation. We're just keeping track of how many frames we've been in the state because that's going to come back here to our states. We want to be able to go back into the move state, the jump state, or the standing slash state from this state. So if we go into the move state, so if the player presses the X input or the frames of state are greater than 8, then go back into the move state. Or if the player presses the jump button, again, jump. It's exactly the same as the move state, jump. And of course, we'll get to the standing slash stuff later on. So I'll just delete this code for now, but you can implement it if you feel like it or whatever. I don't care. Acceleration should be exactly like the move state. So, except the player can't actually, well, player can input, but you know, if he does input, then you go back to the move state, so it doesn't really matter. So in this case, we're just aiming towards towards stopping. That's all we want to do. So very easy, very simple, done. Now let's go check and see how it works. All right, Link is there. And we can jump now. And see, he even does a little landing. He does that for a couple seconds. Then he gets back up as he gets towards the end because he's not in the duck state until he completely stops. But, you know, he's in there for a couple of frames. Isn't that really nice? That was easy. All right. Thank you, everybody, for joining me. I'm going to let past me take it away with some Patreon names now. I'd like to thank my legacy Patreon sponsors: James Burton, JD Lowe, Suli, and Vezia. I'd also like to thank my current Patreon sponsors: Kenneth Klein, Vladimir, and Jamal. Thanks to your support, the NESGameMaker is much cooler, and I'd like to wish you all good luck with your programming.